At the outset, let me congratulate the coordinators of the program, Dr. Hari and Nirmal, and the entire civil engineering department for organizing this faculty development program sponsored by All India Council for Science and Technology. And I hope the participants will be exposed to the newer arenas as well as techniques in this field. And after this, going through this FDP, they will be more equipped and confident to meet the challenges that are facing in and around the workplace as well as place of residence, etc. And especially our civil engineering department will be can do the consultancy work in a better way in which they are already engaged, and this will provide ample opportunities for enhancing our consultancy work in the civil engineering department. So I wish the program more success. Thank you.
Thank you, sir. With great pleasure, I welcome Engineer Punus George, Executive Chairman, Saintgits Group of Institutions, to grace this occasion by his words. Sir, your mic isn't muted.
Respected Chief Guest, Professor Darkar, and our colleagues in Saintgits, esteemed faculty members, and the attendees of this conference. I hope you can hear me. And a very warm good morning to all of you. As you know, we at Saintgits have always thought that the technical education should be a wholesome education, which gives you more 360-degree viewpoints. And in that manner, our late former senior governing board member, founder of the Civil Engineering Department of IIT Madras, Professor Dr. P.C. Varghese, he had suggested that we should have a course which will join the knowledge needed for structural engineers as well as the geomechanical engineers. And as you very well know, any structure cannot be devoid of an understanding of the soil under it. And the interaction between the structure and the soil and the foundation is always there, whether we want it or not. So it is always better for a civil engineer, while he goes down the path of acquisition of his knowledge, to be more wary of the geomechanics. And it is always good for a geomechanical specialized engineer to know what is the top structure, what is the overhead which is happening. So in that manner, we have the postgraduate department of civil engineering has 2 MTech programs, one in MTech in structural engineering and construction management, and one in geomechanics and structures. And you all will agree that because of the scarcity of land, now there is a lot of construction going on in reclaimed lands, especially in cities where there are adequate soil support is not there. So in a way, structural engineers cannot ignore the geomechanics involved in the place of his design. So in this aspect, it is rightful that the civil engineering department, under the stalwart leadership of our Professor Ribu Sakria Koshi and Dean Dr. Susan George, to take up this very valuable conference. This subject is of interest to all of us. Actually, let me also, as an aside, tell you that yesterday we had a national conference on the new educational policy, which was, the chief guest was our most respected IICT chairman, Dr. Anil Sahasrabudhe. and it was in Bangalore. And he is one of the main persons who is involved in the Prime Minister's closed committee, which finalizes the national education policy, which is implementing that now. And so almost all the speakers, including the AICT chairman, was telling about the technical qualified personnel who come out of the institutions or who are becoming more and more in their respective fields to acquire, the need for them to acquire multidisciplinary knowledge. In fact, the NEP lays great stress on that. So in a way, we are having that aspect also taken care of. So I would like to compliment the entire faculty as well as the coordinator Nirmal and all those who are behind the success of this conference, and wish all the participants a good experience from this conference. Thank you. Thank you so much.
Thank you, sir, for your kind words. I now cordially welcome Dr. Hari Ji, Professor, Department of Civil Engineering, and the coordinator of the Faculty Development Program, to introduce to the gathering our chief guest of the day, Dr. S. Chandrakaran, Professor, Department of Civil Engineering, National Institute of Technology, Calicut.
Our chief guest, Dr. Chandrakaran sir, Principal, Executive Chairman, Head of the Department of Civil Engineering, Dean Civil, and participating guests and my dear colleagues. First of all, I would like to welcome all of you to the present here for this ATAL FDP program in geomechanics and geomechanics for structural engineers. I have immense pleasure and privilege in introducing Dr. Chandrakaran, Senior Professor at the National Institute of Technology, Calicut, to the gathering. I'm sure that most of the people present here is already aware of him, because he is a known person in Kerala, especially a top expert in geotechnical engineering. Chandrakaran sir graduated from Regional Engineering College, Calicut, presently the National Institute of Technology, Calicut. He had his master's and doctoral degree from Indian Institute of Science, Bangalore. He joined REC as a faculty and continued his teaching saga till date. He has more than 35 years of teaching and research experience. He has successfully guided 12 PhD theses and presently is guiding about 7 PhD scholars. And he has guided more than 70 postgraduate students. In 2020, he has received the Best Engineering College Teacher Award, constituted by the alumni of NIT. Coming to his research interest, he has a specific research interest in, especially in soil behavior, ground improvement techniques, landslide mitigation, environmental geotechnics, foundations, and machine foundations. He is a renowned geotechnical expert in Kerala and was consultant for hundreds of various geotechnical projects in Kerala. At this time, I had to mention one special thing about him. Even though he has this much credentials, he's a very nice and humble man. And also, I would like to add with great pride that he was my research supervisor at NIT. I'm requesting all of the participants here to make use of his knowledge and extract as much as from him in the coming section. Sir, I invite you to kindly inaugurate the ATAL FDP and enlighten our participants with your knowledge. So please, thank you all.
Thank you, sir. We are truly obliged to our chief guest of the day, Dr. S. Chandrakaran, Professor, Department of Civil Engineering, National Institute of Technology, Calicut, for accepting our invitation to inaugurate and shower his blessings on this 5 days faculty development program. I am delighted to welcome Professor Dr. S. Chandrakaran to formally inaugurate the program and also for the inaugural address.
Respected Engineer Punnus George, Principal Dr. Joseph, Dean Dr. Susan George, Head of the Department, coordinators of this program, then dear participants, I am very happy to see that one of the well-known college of Kottayam, Saintgits, is taken up a FDP on geomechanics and structural engineering, which is one of the needy topic for the civil engineers, and lot of research activities as well as the modifications are coming from the field, which has to be updated. Then only one will be able to utilize these informations. And this type of FDPs will be helping us, the participants as well as the speakers, to interact and to gather more and more knowledge in this area. And in this occasion, I would like to quote one consultancy that I got last week, that is in Cochin Island. They are constructing some flats and they want to make STP. And STP during construction, sheet pile has been failed and collapse has taken place. And we are asked to intervene and give the solution. When we check the information, first we asked the soil data, then we asked about the structural data. Then when we cross-check, I really happen to see that Dr. Hari has given the soil report, and the soil report is exactly matching with what is seen in the site. We have done the reboring and the same values have been obtained. And that way, say this, and we are just preparing the solution, and we will be giving the solution by this week. And this type of courses will help us to gather the knowledge as well as to communicate or utilize in the field. That is one of the advantage. That way this FDP will be very, very useful to all. I once again congratulate this institute, Saintgits, for taking up this type of FDPs rather than going purely academic type of FDPs. And with these few words, I will inaugurate this FDP and say this will be very smooth. I request all the participants to attend all the sessions and try to interact with the faculty so that you will get more and more knowledge. I wish it should have been offline. That was more and more better, but we cannot avoid this type of situations. Thank you.
Thank you, sir, for your words and blessings. We are truly honored. I humbly request Professor Dr. Susan George T., Dean, Department of Civil Engineering, to deliver the gratitude note.
Hello, am I audible?
Yes, ma'am.
Respected Professor Dr. S. Chandrakaran, Department of Civil Engineering, National Institute of Technology, Calicut, Engineer Punus George, Executive Chairman, Dr. Joseph Kunyapolsi, Principal, Dr. Ribu Sakriya Koshi, Head of the Department of Civil Engineering, coordinators of the ICT program, Geometric Mechanics for Civil Structural Engineers, Dr. Hari and Engineer Nirmal, participants from various institutions, and my dear colleagues. Good morning to all. The present changing climate resulted in more intense tropical cyclones and storms, more intense rain events and flooding, and other climate-related hazards definitely require some intensive discussion on the topic geomechanics for structural engineers. I hope this FDP will provide us not only essential knowledge but also a great opportunity to share experiences about technical and regulatory issues. I would like to take this opportunity to congratulate the organizers for the inclusion of experts from IITs, NITs, industry, leading research and academic organizations in India and abroad as resource persons. Today, Professor Dr. S. Chandragaran, who is an erudite scholar and an academician of the highest caliber, doing research on different areas of geotechnical engineering, is with us. Such distinguished works are recognized with many awards in India. Sir, I express heartfelt gratitude to you for the inaugural address and at this program as a resource person. Thank you, sir.
Thank you, ma'am.
Engineer Punus George, our executive chairman of our college, is the perpetual source of inspiration for all of us. Sir, we are fortunate to have you in our midst today, and on behalf of the department, sir, I express our sincere gratitude for gracing this occasion. Our principal, Dr. Joseph Kunyabolsi, president of the function, I express our heartfelt thanks to you for your encouraging words. We are delighted to have you all delegates to attend FDP. I extend a gracious and inclusive thanks to all of you. I also thank our head of the department, Dr. Ribu Sakriyakushi, coordinators of the FDP, Dr. Hariji and Engineer Nirmal, and all faculty members of the department for their support and cooperation. Once again, thanking you all. I remain. Thank you.
Thank you, ma'am. With this, we have come to an end of the inaugural ceremony. Thank you for your valuable presence and cooperation. Wishing you all a happy day. Thank you once again. There is an announcement. All participants are requested to kindly stay back for the first session of the day by Professor Dr. S. Chandragaran on the topic Design of Machine Foundation.
Dr. Hari, can I start?
Sir, you can start. Pardon.
Okay, I'll start. Can you hear properly?
Sir, we can hear you.
Okay. First, I'll share my screen. I hope you can see. Hello? Hello? Visible.
Yes.
Yes. Yesterday, I had a talk with Dr. Hari, and I felt I'll be talking on design of pile foundation rather than the machine foundation.
Yes, sir.
This is
Yes, sir.
highly useful to the many, say, structural engineers as well as geotechnical engineers. That way, I slightly changed the topic. And say first part, I'll be talking about the theory, and second part, I'll be sharing with you some of the experiences that we come across in the field. So to start with, I'll be giving some details about the deep means pile foundation, then what are the various types of pile foundations, and how the piles are classified, and how we can go ahead with the installation, then pile spacing, then negative skin friction, etc. This is purely from the theory point of view. The first part, some 1 hour I'll be talking. The next 1 hour I will try to share some of the field experiences. Any problem with the sound? Hello? Is it okay? Can you hear smoothly? Some sound disturbance is coming. So some of you mute it, then it will be some Om Prakash, mute it so that this. I request the participants to mute, otherwise some sound disturbance is coming. Now, pile foundation is the foundation that provides support of the structure from the toe resistance. The toe resistance we call it as end resistance. This is the end resistance. And it may be from a firm soil. It may be a dense sand or it may be a hard rock. And from the shaft resistance that is generated by the skin friction that is developed. So there will be two components. One is known as end bearing and the other one is known as the frictional component. If the load carrying capacity is mainly contributed by the end bearing, we call it as end bearing pile. And if the load contribution is coming mainly from the friction, we call it as the friction pile. Generally, the pile will be taking the load from end bearing as well as from the frictional component. Both the components will be taken care, and depending upon the site condition, end bearing may be dominant, or sometimes if the structure is small and you will be able to satisfy with the friction alone. We call the pile as foundation as D foundation when the depth to width ratio is greater than or equal to 4. And whenever the bearing capacity is low and we want to overcome the soft soils that are present, then only we will go for the pile foundations. That is when we will not get proper bearing stratum at shallow depths. Heavy loads from the superstructure are likely to come, and we feel that shallow foundation may not be economical or feasible type. Then also we'll go for the pile foundations. The D foundations may be classified as a pile, pier, or caisson, or well foundation, and sometimes sheet piles also included in this. Among all, nowadays caissons and well foundations are getting outdated because the labor involved in the construction is very high, and the difficulties in the construction of caisson and well foundations are more. In that cases, the piles are replacing the type of the caisson and well foundations. Caissons or well foundations are heavier in section and they are sunk to the required depth, and the process is a little bit tedious process. The pile foundation means a post. It may be made up of concrete, steel, or timber, or a suitable material, and that acts as a structural element for transferring the loads from the superstructure to the deep where the strong or the firm strata is available. The basic difference between the column and the pile is confirmed by the soil, whereas column is a freestanding structure. Sometimes this pile also may become a slender member depending upon the availability of the depth of firm strata depth. And sometimes this pile may be subjected to moments as well as the lateral loads. That possibility is also there. Now I am just going through different steps involved in the construction of pile foundations. I hope this is clear. One is erection of the rig. Rig means the 3 legs and a center there will be a pulley. Then we will try to do what is meant by boring or making a hole on the ground. And for that purpose, we will be using bentonite slurry inside this hole so that caving can be avoided. And parallelly, a team of reinforcement will be preparation of the reinforcement cages. So they'll be preparing some, keeping some stand and try to keep the reinforcements. Then the third one is reinforcement will be inserted gently into the borehole without touching the sides. And after that, termi pipe that is used for concreting will be inserted. After inserting the termi pipe, say it will, the top conical end will be kept in the top, and design mix will be prepared in the, and it will be transferred into this hopper. And finally, this termi pipe will be lifted stage by stage, and during that process it will be given some shakes. And shakes means it will try to move on all round, so that some compaction will be achieved. That is, the third stage is lowering of the termi pipe, and the fourth one is pouring of the concrete. Then after preparation of the or after installation of the piles, we do what is known as pile chipping. And after doing the pile chipping, we will be going for the, what is the structural element called pile cap. That is the intermediate structural element between the superstructure and the foundation. The pile cap may be connecting large number of piles, maybe 2 piles, 3 piles, or 4 piles. Sometimes it may be a continuous strip type. And after the construction of this, along with this pile cap, we will be casting the columns. And before going into this, in the code, it is it says that we have to test some of the weaker piles that is required. We have to do the tests on say some of the piles, and that has to be done in order to confirm the load carrying capacity that is obtained from the calculations are matching what is with the field conditions. These are the steps involved in the construction. Now I'll go for the classification of the piles. We can call the pile as end bearing or compressive strength type of pile, and provided it transfer the load to a hard stratum. Second one is the pile may be used to take care of the scour depth that is coming in the river, or say wherever the tidal effects are there, we have to take care of the scour depth. Then the pile may be classified as tension pile or uplift pile, and if it is used for taking care of the uplift, we call it as uplift pile. Sometime in the electrical towers, if there is a breaking of the wire, there is a chance that the tower may tilt. In such cases, the pile may be subject to tension. Such a tension or uplift piles has to be taken care. And the piles has to be taken care for the horizontal loads also. And depending upon the requirement, we change the type of the pile to control the wire, say control the anchoring, or sometimes fender or batter piles, etc. And in the machine foundations, in order to control the vibration that is transmitted by passive, we call passive vibrations, that has to be controlled. And for that purpose also, we can use along with the foundation piles. Then we have another type known as compaction piles that will be used for ground improvement in the form of columns that can be used like that. Depending upon the function and depending upon the type of the load transfer, we can give different names. And the classifications are grouped as based on method of construction. Method of construction means we can have hand augers, we can have chisel type of drilling, we call DMC piles, or we call if we are using rotary type system, then we call it as a rotary pile. Like that, we can give different names. Then it may be precast pile or it may be cast in situ pile. Like that, depending upon the type of construction, we can give different names. Again, based on the materials, it may be timber, steel, or concrete, or composite we can call. different with the different names. Then material of the load that is transferred, we can give again, we can give the composite types are there, many names can be given. Then the function of the pile is to transfer the load again based on the shape and size. I'll just show these things. I'll come to the shape. Before that, say there is another one. Nowadays we come across low volume displaced piles. What it means is, while boring, we will be displacing some of the soil below. That may be low, or sometimes it may be no volume displaced piles. And if all the soil has been displaced, we call most of the soil has been displaced, we call it as high volume displaced piles are known. And this can be controlled by the type of the machinery that is used for boring. I'll come to the shape. We can have rounded piles, square piles, octagonal piles, eye-shaped piles, straight piles, or tapered piles, or bell-bottom piles, or screw piles. Like that, we have different piles. And this seventh one, in Chennai, some company is making Raymond piles. They have their own patent, and they are trying to make that type of piles. Like that, we have different names have been given depending upon the shape. These are some of the shapes. This is mainly used in steel piles. Then pile can be classified depending upon the size. We can call it as a large diameter pile, or we can call it as small diameter pile. Large diameter pile definition is given as greater than 24 inch. It is around 60 centimeters. And this classification vary from code to code. Some of the books it says more than 100 centimeter, you can call it as the large diameter pile. Less than 100 centimeter, you can call it as small diameter pile. Then we have another group called micro diameter piles that is mainly used for restoration techniques, and also for the ground improvement techniques, etc. that can be used. And this way also one can classify the piles. Then how a pile look like? Says look like a single long member transferring the load from the top to the bottom, and it may be, say, resting on a hard strata, then we call it as a point bearing pile. And if the surrounding soil also contribute in the load carrying capacity, that contribution is known as friction pile. And if the pile is used to take care of the uplift, buoyant forces, we call it as a uplift pile. Like that, we, depending upon the need, we may say group, or we may use or the design the pile accordingly. Then depending upon construction, say this is a precast pile, pile will be kept straight, and you will be hammering and allow the pile to go down. And the hammering should be in such a way that the soil should not get displaced much. That has to be taken care. And you have to see the verticality also is maintained. In the case of board piles, first the boring will be done with the necessary tools. After making the boring, the cavity will be filled with the concrete. First the reinforcement will be introduced, then cavity will be filled with the concrete. If you are filling the cavity first with the concrete, then inserting the reinforcement, we add one name, compacted cast in situ pile. Like that, we'll modify. Now, the design can be done based on the soil data that is available, and either it may be laboratory data or it may be field data. But after the design, when it goes to the field, one has to take care the installation. Installation is also going to affect the load carrying capacity. So that way, installations are very, very important. In the case of the precast piles, installation by hammer, pile hammer, or in the case of cast in situ pile, the boring by mechanical auger has to be used. Now the installation technique has to be decided based on the site conditions. That has to be, say, well studied before going for the installation. For example, in Calicut, we come across a hard lateritic layer 5 to 7 meter below existing ground level. In many places, that hard layer breaking will be transmitting a lot of vibrations to the nearby areas. In such areas, DMC pile is not advisable. Likewise, if the soil is having very low N value, when you say make the boring, there is a possibility that the caving can take place, or the boring may not stand by its self weight. So some liner may be required. That also you have to take care in the installation. So installation depends upon the size and weight of the pile, the driving resistance which has to overcome to achieve the design penetration, the available space and the headroom on the site. So whether the tripod can be kept, or you have to use for low tripod, smaller tripod, like that you have to, and the space available also has to be taken care. Then the availability of the cranes has to be taken care, as taken to account which may be in force in the locality. So that also has to be seen. Pile driving methods are by dropping weight, by explosion, vibration, jacking, jetting. All these are used for the precast piles. Now the piles may be classified as a driven precast piles. That is one group. The pile is casted in the yard, brought to the site, and driven by some mechanism into the soil. Or driven cast in situ pile, a casing plugged at the bottom is driven into the ground, and then the pile is casted by removing or retaining the casing. Then bored precast pile, a boring is made and the soil inside is removed, and then a pile is casted in some yard, is put into the bore. Then bored cast in situ pile, a bore is made, the soil is removed, and the pile is casted at the site in the bore. Likewise, depending upon the procedure followed, the different names are given. And this is for say precast piles. We have different types of machineries like drop hammers, single acting steam or compressed air hammers, or double acting pile hammers. Like that, we have different machineries available, and the efficiency of the system will vary from the hammer that is used. For example, if you go for double acting pile hammers, the efficiency may come around 0.6 to 0.7. And if you are using drop hammers, the efficiency may be 0.3 to 0.4. So again, depending upon the site conditions, we will select this, and the feasibility and the requirements will go for the type of the hammer that is required. So installation by boring, what is done is we will do boring first, then we will be going for the filling with the concrete gradually, and before that we will be introducing the reinforcements, and say we will complete the piling. These are the elements that is involved in the pile driving with the hammer guide, soil, drop hammers, drop hammer guide, then pile precast or cast in situ. Then there will be driving shoe for the precast piles. This one I'll skip. Nowadays, helical augers are also used for the rotary boring. One advantage of this helical augers is while taking out, we can clearly see the soil that is coming out, and we will be able to compare with the soil data that is available with the soil that is available in the borehole data can be compared with what is taken out. So that way you can ensure that the design that is done is okay. This is precast piles. I will be showing this again. I am just showing you the rig and the details. Now, just 1 minute, I'll just join. Okay, I'll continue. What are the loads that is coming on the pile foundations? The loads that are coming on the pile foundations are basically the load from the superstructure, that is dead load, live load, and wind load, and seismic loads. Then the loads from the surrounding soils. In the case of seismic event, there will be lateral loads. Then in the case of offshore structures, there may be water loads, wave loads, etc. Has to be taken care. If the pile is on the land, we have to take care of the dead load, live load, and if necessary, wind load, then seismic loads. So this is the typical loading diagram that is used in the designs. We will have vertical load, moment, and the horizontal load, and we will be considering the soil layers, different properties, and then we'll be going ahead for the designs. Now, a single pile is generally not advisable. So in order to take the column load, we will be using a group of piles, and the group of piles maybe generally is given in the symmetrical form, and there are methods to get the spacing of the piles, that is spacing to diameter of the pile, and larger the spacing, larger will be the size of the pile cap. Smaller the spacing, lesser will be the size of the pile cap, but the load carrying capacity of the pile will be reduced. And if there are some horizontal forces, say we have to add raking piles on the edge so that horizontal force will be taken care. Now, what are the ways the load will be transferred from the pile? It depends upon the type of length of the pile, it depends upon the diameter of the pile, it depends upon the soil strata. If we have strong end bearing, we call it as an end bearing pile, and generally the load carrying capacity is generated from the end bearing come friction. If the structure is transmitting only small loads and there is no end bearing, then the load carrying capacity will be only from the friction. That is, pure friction piles are used. Now, if the pile is very small, generally we call it as a short pile, and the minimum length of the pile that generally we prefer is 3 meters, and the load will be taken, load capacity is calculated from the bearing capacity equations. If the pile is very long, then we have slightly different bearing capacity for a deep layer has to be used, and we have slightly modifications in the calculations. And if the pile is very long, we have to take care of the buckling possibility, and due to the lateral load, etc., has to be taken care. Now, these are the mechanism by which the load will be transferred through pile. In order to calculate the load carrying capacity, we will be using geotechnical capacity, that is, by considering the soil parameters, we can calculate the load carrying capacity. Second one is we can calculate the load carrying capacity from when the pile is acting as a structural element. In that case, we will take the load as the load carrying capacity as a column. The difference between the design of column and the design of pile is surrounded by the soil, so we have to consider the confinement, that is an advantage. So effective length of the pile will be reduced, and based on that we'll calculate what may be the effective length. Then we'll take L/D ratio, then we'll consider whether it is a long column or short column. Then we calculate the load taken by concrete and load taken by steel, and we'll sum it up. This is how it look like the load end bearing reaction as well as the skin friction, and the top vertical load that is coming will be taken by the head. Now, these are the ways in which the load will be taken that I just already explained. In the case of lateral loads, we can see that the pile may be getting deflected. That also has to be considered when there is a significant lateral loads that is likely to come due to the water pressure or due to the seismic action. Now, in the case of uplift, we have to consider the pile in tension also. Pile in tension also has to be considered. That we have to either the pile may be subjected to compression or the pile may be subject to tension. Both has to be considered. Now, these are the ways in which the load will be taken care. The load is calculated for the axial capacity, then the lateral capacity, then pull-out capacity or tension capacity. If we are doing the load test and try to get the load carrying capacity, generally people prefer for the axial capacity, then the other two will be derived from that, lateral capacity and the pull-out capacity. The testing on pull-out we can do for small piles, but say long piles it will be slightly difficult. There are procedures for finding out the field test for finding out the lateral capacity also. So whenever we want to do the design, we need axial capacity as well as lateral capacity as well as pull-out capacity, or what is called tension capacity. All the three are required. And IS code has given clear procedure for the calculation of the axial capacity for the clayey soils, if the soil is clay or sandy soil. And from that, we have methods for the calculation of the lateral capacity and the pull-out capacity. Basically, we can do this by field approach as well as theoretical approach. Field approach means, say, whenever we want to design pile foundation, we have to do soil boring. And the soil boring will be done, samples will be brought to the laboratory and the sample results will be obtained. But the difficulty is we will have only limited data and we presume that the same data is applicable for the whole area. Instead of that, one can do a test in the field, cast a pile, do the test till it fails, then back calculate what may be the soil parameters that is involved, and from that we will be able to go ahead with the design. That is known as field approach. Theoretical approach means based on the calculations, based on the formulas given by the researchers or from the code, we will be able to get the load carrying capacity. Both are possible, and the disadvantage of going for the field approach is you have to cast a pile, you have to cure it, then you have to test it. By the time the certain period will be lost, construction period will be lost. After that only you will be getting the data, then only you will go for the actual design. So it is a time consuming, also it is costly. Other method is based on the laboratory test data, we will be doing the design. In that case, we have to do what is known as a routine load test. And as per the code, I think it is for every 100 pile, we have to do one routine test. In that case, we will not allow the pile to fail. We will go only up to the allowable settlements. Then we will start doing unloading. And such a load test or else, I will be explaining again that one if time permits. And otherwise, nowadays we have the NDT tests, like a strain tests are available, like a low strain integrity testing or high strain integrity testing are available. Load tests also can be done for the dynamic loads, it can be done for lateral loads, or can be done for cyclic load, etc. are possible in the field. Now, pile load test is essential. We cannot avoid that. Pile load tests are usually carried out for the following main reasons. One is to ensure that whatever that design done is perfect or is satisfying for a particular site. Then to confirm the pile length, hence the contractor costs before the client. That has to be done in the beginning so that we will get an idea about the depth and other details, or the type of machinery that is used, as etc. can be obtained. Then verifying the structural soundness of the pile, whether it will be working or not, that also can be ensured. Many advantages are there for doing the pile load test. Earlier, people were making a platform and filling with the sand. Surrounding, you will be keeping, say, gunny bags filled with the sand. Then inside you will be filling with the sand or aggregates to get necessary reaction. This, because of the labor involved and the availability of the material, etc., considered, nowadays people are going for the standard blocks. You can keep one block above the other and able to make this type of loading. That is possible. Now, from the load test, we'll be getting load settlement graph. We'll have, and here it has plotted x-axis load and y-axis settlement. The load settlement graph, when it almost fails, we will start unloading almost in the same manner, and we will get the rebound curve. From the load settlement graph, there are procedures for calculation of the tip resistance. Here you will get the end bearing resistance. This part you will get the frictional resistance. So you will be in a position to get end bearing resistance and the frictional resistance. One can calculate back what may be the cohesion that is developed, and what may be the bearing capacity factors approximately, or end bearing resistance is known, so we can redesign if necessary. That is also possible from the see about the theory part. Now I'll go to the second one. Now, some of the problems that is seen is when the pile is socketed in rock, say what depth you have to socket it. For example, say in Malabar area, we come across lateritic soils, and below the lateritic soil, we come across weathered rock. And if the weathered rock is existing for a large depth, then only hard rock is coming. Is it necessary to go up to the hard rock or not required? Such questions are likely to come, and how we can do that. That is what I want to explain in this coming PPTs. The pile socketed in soft rock and weathered rock. The pile is socketed on hard rock. There are codes, and different codes are giving different amount of the socketing. For example, if you refer IRC, they are telling 50 centimeters. If you refer railway code, they are telling 1 meter. Like that, different values are given. So socketing depends upon the type of the structure that is coming about and the need. We will go for the socketing. Second part is some construction problems that I'll be showing you. Now, in the sedimentary as well as the weathered areas, we come across soil, then gradually it will reach the rock. That is the procedure that is seen. That is the soil strata that is seen. Now, we can get the strength of this rock by conducting SPT tests. We can do pressure meter tests. We can take undisturbed samples and try to do unconfined compressive strength test, etc. Now, the N values generally varies from 0 to 60, and soft rock and weathered rock, we get N values around 60, and very hard rock, we can get any value. And N values, to some extent, it will help, but doing SPT tests in a hard rock and comparing 100 and 200 may not be that good. Now, the socketing length means how much it will be entered, or how much you are making the pile into that particular layer. That is what is meant by socketing. Since here the pile is vertical and soil strata is horizontal, this is defined as the socketed length. This is known as pile tip. Now this particular pile is resting in the soft weathered rock. Above that, we will have different types of layers. Now, if the weathered rock is getting a profile of inclined direction, then we call this is the socket length. This part is the socket length and not this part. So minimum socketing length, if we define, that has to be satisfied in the lower side. Now, it is very difficult to get whether the soil is whether soil is hard and whether we can stop that pile at that particular depth. Generally, we have to do some kind of testing, and we have different methods of testing. I told you one is SPT. SPT is not 100% say reliable for this, because SPT 200, 300, etc. we cannot compare, and also it is tedious to do SPT to that values. Another one is during soil boring, we will get some RQD and rock recovery, etc. Based on that, we will be able to tell whether the particular layer is hard or not. Otherwise, we have to do some UCC test, get the crushing strength, and ensure that that is satisfied. These are possible in the case of the before going into the field. Now, as per the code, we can go if the hard layer is defined, that is reached, something like if you are expecting 200 kilo, say 2000 kilonewton per meter square is expected in the crushing strength. If that is reached, you can go as 2 to 5D embedment. D is the diameter of the pile, and the experience says 2 to 5D is sufficient. That is what some of the field people have reported. Now, the best method among the many methods that are available is Collet and Strud approach. This is also available in the code. And in order to get the embedment depth and the load carrying capacity, we can go for the Collet and Strud approach. And in this, whether the hard strata is arrived, necessary hard strata is available. I am telling not the rock, in the weathered rock. Is it satisfactory? That is generally given by what is meant by chiseling criterion or energy approach. Most of the practical engineers are following this. What is meant by this chiseling criterion? Chiseling criterion means the structural engineer or the geotechnical engineer who is designing the pile has to define what is the weight of the chisel that is to be used, and what is the height of fall, and how many times you have to give the hit, that is the energy, how much energy you are transmitting. During that energy transmission, what may be the settlement or what may be the penetration, that has to be noted. So energy criteria we will calculate depending upon the weight of the chisel, the energy transferred, and the amount of the settlement or penetration can be related. And that if you adopt, there is no need of doing SPT or some other test in the field to ensure that the hard strata is reached. Necessary hard strata is reached. So this energy value will change from project to project. That has to be given by the engineer, and that has to be followed in the field. Then only we'll be able to tell. It is much better than going for the SPT test or taking an undisturbed sample and finding out the strength, etc. This will be much better. And this has been practiced by many practical engineers in the field. This part I'll skip. So basically, it is written in Mumbai. It is well established, and some of the terms that are used are, say, 10 centimeter if you are using 750 ton meter per meter square for 3 consecutive trials. Like that, one can give. In such cases, no SPT test is required. Penetration varies greatly with the weight, height, and type and shapeness of the chisel edges and the amount of chiseling done earlier. So that has to be considered. Then only we'll be able to give the chiseling criteria. So socketing can be done even in weathered rock or soft rock, and say one can construct the pile. There is no difficulty, provided the weathered rock is available for large depth and you are not in a position to go up to the, you can go up to the hard rock, but that is not worth. Now the second part is some construction problems with the suggested solutions in piling. I will be giving one or two here. One is reinforcement cages. This is how the reinforcement cages are prepared. The longitudinal bar or the main bars and the ties has been defined in the structural drawings, and this is one of the cage that is prepared. You can see here the straight bars and they are beautifully bent. In the bottom, the structural engineers do like this for fixing of the beams, etc. Whether is it required in the piling or not, that is the point I want to discuss today. The second one is the lateral ties. We write as 8 mm or 10 mm at some particular spacing. But in piling, what is done is in the helical form, the reinforcement will be tied, and every regular intervals, some tie rod will be welded inside. So that is the practice that is followed. Now, what I am telling is this is not a good practice that is followed. In the second slide also is not a good practice. You can see here the longitudinal bars are there, then bars are bent at the bottom. Then these are stacked in reinforcements. You can see here this storage practice is good because that is not touching with the soil, so corrosion possibility is lesser. But in bend, L-bend practice is not good. Again, they are bent like this. Now, this is not a good storage practice as well as the L-bend practice. You can see here the reinforcement cages are made and it is simply dumped on the ground. And finally, it is getting corroded because of the soil may be having some acidic nature. It is getting corroded very fast. Also, L-bend practice are not good. Now you can see in this particular one that there is no L bend, just for the namesake they are bent like this. The reinforcements are bent and the bottom one is opened fully. And I forgot to tell this type of things that is known as the covering blocks that will be tied along with the lateral ties. This is a good L bend practice with a small L bends. Theoretically, we don't want any kind of L bends. And also good storage practice. Now I am just showing you there is no need for any reinforcement at the pile tip. That is the need. This is as per the requirement. There is no need for any L bend. The L bend, what it creates, L bend bending prevents the termi pipe reaching the borehole bottom. Termi pipe is the one which is used for concreting. It will not reach the bottom. It will be standing on the reinforcements. Then concreting to termi pipe by displacement cannot be achieved unless the termi is initially placed to rest at the pile borehole bottom. That is one of the difficulty that is seen if you go for the L bends. So L bends prevents good concreting and is to be eliminated. If some designers wants L bend for the cage for proper resting on pile hole bottom, then just namesake you can give some 3 centimeters or 5 centimeters that can be provided. That is more than enough. That will be much a good practice that will be followed. Now I am trying to explain why that is happening. First, you can see in this sketch the boring is done. Boring means you will be, with the help of the machinery, you will be making a hole in the ground. And during that process, initially they will be using a small casing pipe. Thick lines shown here are the casing pipes. That is known as guide casing. Guide casing is used only for 1.5 to 3 meter. If you use more than 3 meter, taking out will be a problem. That is one of the things. And some cases they may break in the joints also. That is another problem that is seen. So generally field engineers prefer only 1.5 to 3 meter. That is more than sufficient. It will not create any problem of falling of the soil from the surrounding. And inside this will be circulating the bentonite slurry so that the caving problem can be controlled. Now theoretically our lines are straight, but in practice you can see it is in the curved form or some shape, arbitrary shape will be formed. Now you can see groundwater level and the ground level etc. are shown. And after making the boring, you will be inserting the reinforcement cage into the borehole Then on the reinforcement cage, you will be inserting the termi pipe. Now you can see when you insert the termi pipe, it should rest on the in the borehole. It should not rest on the reinforcement. If you do L bend, it will rest on that. That is not required. After that, you have the plug. That plug will be closed, and the design mix will be mixed in the mixer machine, and that will be transferred up by opening the plug. Now you can see the concrete has gone up to the bottom, and you have to see that this is gently, your termi pipe is gently taken back. The procedure that is adopted, is termi pipe will be lifted by small lifts. The depth of the lift is 0.2 meter to 0.3 meter, and you will be giving some compaction inside, so that your concrete will be compacted. And you can see here the concrete will start displacing through the sides. When you lift, the concrete will start displacing through the sides, and it will start coming to the top. And during that process, you can see some of the soil may be mixed with this concrete, and sometimes bentonite slurry that is mixed with the concrete, etc., will be coming to the top. So that is known as the top portion of the concrete will be not be a good one. Now the top portion may not be a good one. That's why people are telling, say, pile chipping is essential, and you have to do the pile chipping so that good concrete in the pile will be exposed. Then another problem that is observed is while inserting this reinforcement cage, there is a possibility that it may touch the sides. When it touches the sides, there is a possibility that some soil will be falling inside the borehole, and that may give some amount of settlements. This possibility also we cannot avoid. So some sedimentation material may be there. Then inside we may have some borehole with the bentonite slurry. Then larger reinforcements, if necessary, we have to insert it properly, make it vertical, and gently bring it down. Then if the length of this reinforcement cage is more than some 12 meters, what is done is from here they will weld. First 12 meter will be inserted, then they will weld, and the next part will be inserted. Then another point I would like to add is this termi pipe nowadays minimum diameter is some 20 centimeters. So if you are using some board piles, so minimum diameter that has to be used is 40 centimeters. Even though the code says start from small diameter, it's difficult to make pile less than 40 centimeters, and it is not worth also. So minimum dimension we have to go 40, 50, 60, like that in the case of board piles. Then the top portion of the pile will be mixed with bad concrete, a mixture of bentonite and some soil that has to be chipped off. And this chipping can be done with the help of chisel and hammer. That is one method. Another one is the vibratory hammers, also used to some extent. That also can be used for breaking. And this breaking will be done till you get the fresh concrete. There are some contractors, they will be using big vibratory hammers that will be affecting your pile. If the pile length is very small, and if you use some hammer like Bosch hammers for breaking the concrete, the micro crack can be formed inside the pile, and that will affect your load carrying capacity. Another point, say here we want to stress is, say this is another point I want to stress is whether the pile chipping has to be done soon after the concrete or after curing. So many debates are ongoing. Also, it has taken place, and some of the leading company engineers, what they are telling is it is preferred to do soon after concrete, so that the concrete will be fresh. That is, don't wait for any kind of curing. Soon after concrete, you try to remove that, so that the removal will be easy and it will be ready for making the pile cap. That is what they are telling. So the chipping can be done soon after the piling. That is, instead of going for the chipping after curing. After curing, the concrete may get hardened, and when you start using vibratory hammers, there is a chance that the cracks will be formed. It is recommended, what is written, I am just briefing out. It is recommended to use chisel or small vibratory hammers in order to chisel it. That is the best one. And the removal should be done till you come across the fresh or green concrete. And from that step onwards, one will be able to make the pile cap, or if necessary, some people may build up and go to the required height. That is also possible. Now, this cleaning of the borehole also got some procedure that has to be followed. Then only the borehole will be fully cleaned. Otherwise, some material will be left out. So for that purpose, we have to do proper mud circulation, then reverse mud circulation. All these things has to be followed. Then only we will be getting the correct clean borehole. That has to be done properly. Otherwise, some material will be left out, and that may give in situ settlements. Another problem that is observed in the making of the pile in sandy soil is, after making the boring, and if you start inserting your reinforcement, it will not stand in its position. It will start moving up and down. That is one of the problem that is seen. And in the case of sandy soil, while making the pile, it is observed that whatever pre-calculated concrete, generally people pre-calculate what is the amount of the material that should be gone into your borehole. And in the case of pile made in dense sand, or in the sandy soil, some concrete will be left out. That is one of the observations that is seen. And in that cases, we have to do the removal of the termi pipe in a very, very cautious manner. Second one is density of the bentonite that is used in the borehole has to be controlled, make it more thickened. Like that, we will be able to say 95% of the extent, we will be able to make the working better. If you do the piling in clay, and the same procedure is adopted in the sandy soil, there will be a lot of say concrete that will be left out. That has to be taken care. Now, these are some of the problems that is seen. Then you have to see what is the cover that is to be provided, has to be done properly. That also has to be done. That is, cover to reinforcements are mainly calculated from the main reinforcement edge. But you have seen in my photograph, this cover is connected to the lateral ties. So there will be a small difference that has to be taken care by in a proper way, by making the proper cover blocks. This one I skip. And there are possibilities that the pile may rust on isolated boulders. This type of problems are likely to come in the field. The boulder I have shown is not a small boulder. It is not some 1 meter by 1 meter, or it may be 4 meter by 4 meter, or some bigger size boulders. In between the boulders, there may be cavities. Suppose one pile is resting on this boulder, another one is going through the cavity. There will be difference in the length of the piles. Such a possibility is there. This you have to ensure from the soil profile data. Second one is, you can do some kind of electrical resistivity or some NDT test and ensure that the pile is not resting on the boulder. It is having sufficient depth. That has to be taken care. That has to be looked into. That is, after boring, you can do some kind of sounding tests are available, with the help of which you will be able to ensure whether the pile is resting on the boulder or it is resting on the hard rock. And another problem that is observed is in one of the bridge in Calicut, what we have seen is one of the pile is resting at 20 meters, another pile has gone up to 40 meter, very close pile has gone up to 40 meter. Then the load distribution may not be uniform. They want to ensure that this 20 meter is resting on the hard rock. That also by some testing, it is ensured that both the piles are resting on the hard rock. That way it is taken care. And as per the code, all the piles should rest on this, all the piles should have the same depth. Practically it may not be possible. In a group of pile, all the piles should have the same depth, so the load distribution will be uniform. Theoretically we will get like this, practically there will be a lot of problems that likely to come. This is another problem that is observed in the field. If we come across some decayed wood layer or very soft layer or a layer with a negative skin friction, there is a possibility that when you do concreting, the concrete may start moving in the horizontal direction in this weak layer. In that case, some of the portions of the pile may be exposed only with the reinforcements, or the diameter that is available will be very less. Then the second case is some of the areas you may come across some bulging. So this we will be knowing when the pre-calculated concrete has been pushed into your bore road, and sometimes even 75% or even 60% might not have covered. In that case, the concrete that has poured has gone to some other direction. That has to be anticipated. So this type of bulging and necking possibilities are there in some of the soils, and this also has to be taken care while making the piling. And if you come across some hard layer, that is okay. That will give you the straight. So bulging and necking possibilities are likely to come. That has to be addressed. Then any layer that is coming as a soft compressible stratum, we have to take care that will not contribute any amount of the friction. Instead of that, it will give you negative skin friction. So that has to be deducted from the actual load carrying capacity while doing the design. So in the soil profile, you can look the values, N values are very low, or is there any filled up ground, or is there any decayed wood layer. That has to be considered properly in the design. So this one I'll skip. And another problem that come in the underrim piles. Underrim piles I am taking, if the time permits, I'll show few slides. In the underrim pile, there will be some bulb that is formed in the bottommost layer. If the bulb is provided at the bottommost layer, the load carrying capacity will be much higher than if you provide the bulb at the top or in the middle. As per the practice, we can go even 5 number of bulbs. As per the theory, we can go 5 number of bulbs in a single pile, but practically people are restricting only to two bulbs, at the most 2 bulbs, so that the caving or the falling of the soil inside the borehole can be limited. Now, if you look IS 2911 part 3, in that one table is given saying that this table can be used for the design of the underrim piles in sandy soil, clay soil, as well as in black cotton soil, or any type of soil this can be used. Now, this is given in the IS code, and we are using this, and we found the results are working very well. There is no difficulty, and only problem is, say, some of the soils this will not give 100% perfect, but still is working. Another reason is this has prepared very long back, where mild steel was used. Nowadays we have Fe 500 or Fe 550 steel, and the grade of the concrete also better That way, this table is working very well. But from the practice, it is seen that the underrim pile in sandy soil, whether it will work or not, for that purpose, some testing has been done in IIT Chennai. What they have done is they prepared a test pile in a sandy layer. They made a pile and they taken out after the curing, and they checked whether the bulb formation is there or not, or whether the pile is intact or not. Now this is the photograph showing the pile has been taken out. Now the zoomed one I am showing you, this is the type of the bulb that is formed. So there is no bulb that has formed here. Also you can see there is no concrete below. Sand, only sand is left out, no concrete at the tip. Now you can see the size of the bulb. Bulb is only limited. And there is no concrete here, proper concrete. So in the theory part, we may be calculating that the bulb will be taking the load, but in sandy soil, with the utmost care they are done, but there is no bulb formation that is seen. So this type of problems may come in the field. Now there is no good say concrete that is here. Also they are able to peel out the concrete. So underim piling in sandy soils is very, very difficult, and to some extent generally we will not it is not recommended. Even though the code has given the details, practically it will be a difficult process, especially making of the bulbs. These are the things I would like to cover in this set. Now I'll go to the next one. There will be small overlaps, but I hope it will not create any problem for you. Now, I'm just going back to the first one. That is, if we use isolated footing, and isolated footing will make a pressure bulb for the stresses that is developed. And if this pressure bulb is lying in weak soil, that is not desirable. Even if you take very low bearing capacity and try to do with the design, it may satisfy the shear criteria, but it will not satisfy the settlement criteria. In such cases, we will go with the ground improvement techniques. And ground improvement techniques here that showed is if the structure is very small and you can replace the weak soil by a good layer like sand or quarry sand and construct with the isolated footings. If the ground improvement techniques are not working and if the structure is carrying heavy loads, then only we will go for the pile foundations. Now, the present condition, say there are good developments that has taken place, and with the help of these developments in machinery and with our knowledge, we are in a position to cast the piles even in the sea or any place, river, ice, or wherever required, we are able to cast the piles. And we have different types of piling systems also. With that say we will be able to do any kind of piling nowadays. Now if we are using in the sea, there will be small modifications than what we are doing in the on the ground. Say if in the sea the possibility of the corrosion is more, so some kind of liner will be used. So liner, 6 mm liner or 8 mm liner will be used. That is a steel casing that is used. Here some batter piles are used because the wave action may be in this direction. So some batter piles are used in order to control the horizontal load. Now, if you go for the offshore structures, we have again different types of piling, like say tubular piles with a hollow, so that water will be entering and it will be standing vertical. That possibility is there. Then we will have some flat form, or say what is done is, depending upon the site conditions, we may go for fixed platform or combined tower or tension leg or say anchoring system, etc. Many things can be done. So this, with the advancement, we are in a position to do even piling in the offshore. So different systems are available. Only thing, the design will be slightly different from that of the onshore. Even anchoring system is available nowadays. That is also possible. If the anchoring system and with a good platform, they were able to make the rigs. So piling is possible even in the subsea. Now here, some small topics I am covering is, one is the pile design. Pile design can be done with the IS 2911 Part 3. In that, we have input as soil data. This soil data is obtained from the borehole. But you can see in any project, we will be doing only limited number of boreholes. We will not do very, very large number and make a data bank. That is one of the observation that is seen. Now, that will leads to limitation of the soil data. When you go for, say, if you make a very big yard where 10,000 piles are coming, you may do some 10 boreholes. These 10 boreholes will not give exact values. So when you do piling, you will be looking the real soil profile in the field. From point to point, you will be getting the soil profile. But the design, not necessary that it should match with the soil profile that is seen. Soil profile may be uniform or it may not be uniform. If the soil profile is not uniform, our design may affect. That is what is the limitation of the soil data in the design. Second one is, depending upon the machinery that is used for installation, our design load may not be correct. Or if you do the design and use hand augers, definitely the load carrying capacity will be lesser. And if you compare the load carrying capacity for the same pile, which has done, or in a particular area, you make a pile with a rotary rig, with a tractor mounted hydraulic, tractor mounted rig, and another one with a DMC pile, both will give you different values. So the method of installation of the pile is going to influence the load carrying capacity. Then if you look, pierce through the design formula that is available, you can see a lot of empirical parameters are getting involved. For example, the earth pressure coefficient, positive earth pressure K value is going to vary from 1 to 3. We can adopt any value from 1 to 3. That is what is suggested in the code. So if you can take 1, you are satisfying the code. If you take 3, that also satisfying the code. But the design, the number of piles that you are going to get, if you assume 1 and 3 are going to be different, that has to be looked into. So that is one of the biggest limitation. The number of piles may vary from, say, 100 to 150 or even 100 to 200. That can take place. That is one of the limitation of the design procedure. Now, if you look in the literature, you can see n number of research papers are available, different formulas are available. And if you compare the load carrying capacity by one method with the other, both will not match. Some of our students have done the load carrying capacity and compared the end resistance as well as skin friction resistance, and nowhere the results are same results are getting. So there are limitations of the design procedure, and some of the places we may have to do the design only with SPT values and no laboratory test data will be available. There are limitations. Then when we look into the effective overburden stress, we have to consider the overburden stress, especially for piles in granular soil or sandy soil, where earth pressure will be coming into picture. So how much overburden pressure has to be taken? So in Cochin, for example, the piles may be 40 meters or 60 meters. In Calicut, it is not that much. It may be 11 meters or 14 or 15 meters. If we go for 40 meters, the overburden pressure at 40-meter depth will be very, very large. Whether we have to consider the full overburden pressure or we have to limit the overburden pressure. So if you again refer to the literature, the code and experts are given different values. IS code says 15D to 20D, and some of the soils where 5 varies from so and so value to so and so value. Like that, they are given some values, and say exact how much we have to take is not clear, or nobody says. They are given only a wide range. From that, you have to pick the necessary values. Then design of the rock socket. Again, some of the code says 30, 50, 50. Then if it is a weathered rock, I already told you how to do the socketing. That also vary from the vary from project to project or location to location. Then magnitude of the negative drag, how much we have to consider, whether we have to consider full or double or how much, and which are the places that is likely to come. So if you look in a particular site, the negative drag length may vary. In one of the locations may be 2 meter, another location may be 3 meter, another location may be 5 meter. So these are the problems that we come across during the design. That is, we have only limited soil data. Then we do not know exactly what type of machinery people are going to use. That will be seen only after the tender. Then in the design procedure itself, we have some limitations that has to be seen. Then negative drag may likely to vary. Then how much overburden pressure has to be considered, etc., are going to affect our designs. Then say board piles. Board piles can be made with a different machineries. If the pile is resting on hard rock, nowadays hydraulic rigs are available. And earlier we have seen that DMC type of piling is quite common. Nowadays rotary system has come, which will be strictly speaking taking less load than the pile made with a rotary type. Then if you look for the precast piles, they generally we call it as precast segmental piles. It may be large diameter or it may be small diameter, it may be pre-stress pipe type pile, and all these things, and even erection, either it is a 2-point erection or single point erection, etc., is going to change our designs. Then say pile drivability analysis has to be taken in the field. Then only we can go for the precast piles. The precast piles are possible in some of the areas like Alapi. There is no difficulty, whereas in Calicut, I told you some hard layers are coming at 5 to 7 meter below. In there, a lot of vibrations will be transmitted when you go for the precast pile. That is very, very difficult to pierce through. And here only in one location precast pile has attempted, and then people are not referred. Now in this picture I am just showing you the chisel. I was talking about chisel like that. This is the typical chisel. The weight of the chisel can be decided depending upon the type of the profile, and if you want to break, some of attachments will be welded together, or if you want to increase the weight of the chisel, you can increase by adding some weights. And what you are seeing here back color is the bentonite slurry that is poured into your used to prevent caving of the borehole. Now when you go and hit the soil, what is happening is soil will get powdered, and that will be getting mixed with the bentonite slurry, and slowly it will be moving out. And after boring, you will be stopping here, you will block this, then you will introduce the dummy pipe and go ahead with the construction. Now this will be lifted with the help of the power winch that is attached to one of the leg, kept along with the one of the leg. So this person will be able to lift it and allowed to hit. Then after hitting, if you are doing on the dry land, you can use jet of water. Here some people will be using some water circulation through the central hole. Here, the central hole may be available, that also can be utilized for jetting of the water. After doing the concrete, you will be again blocking this. This bentonite will go back to the tank, and that will be mixed very well and diverted to the next point. When you want to make the next pile, the system that followed here is gently you push the legs one after another and see that it will not overturn and reach the next point, and there we'll be doing the piling. Now the end point, that is end tip, can be modified depending upon the need. Here you can see another rig that is used. You can see the bottom one, and say you can see the sharp edges, and say you can see the attachments. This is another one, another type. Now you can see here the rotary rig. Rotary rig, it will be rotated at some particular speed and some torque will be applied, and with the help of the torque you will be able to rotate and make the bore hole. That is the system that is followed. The advantage of the rotary system is it will not disturb any of the surroundings. You can go even very close to the buildings and make the bore hole. Another advantage is after making the bore hole, you can simply rotate with the help of this rig and etc. You can easily, in no time, you can go to the next point and start drilling. That is the advantage. The matter, you can change this teeth depending upon the type of the soil that is coming. We have different types of teeth attachments are possible. The drawback that is seen is some of the soil will be left out in the bore hole that you cannot be able to take out in this particular rotary system. Especially in the tractor mounted rotary system, some soil will be left out or some cone shape will be there in some of the rotary boring. There we will not get exact, say, clean bore hole. So the load carrying capacity will be slightly lesser. And also socketing will be very difficult in the rotary system. Socketing, you have to break with the help of the chisel only. That may not be possible in the case of this type of rotary system. Otherwise, you have to go for hydraulic rigs. Now again, once again, I am showing you some other boring system. Here helical augers are used, and you can see here another sketch, the removal of the soil and the reinforcements that is laid, and generally the concreting will be done up to some height and some reinforcements will be taken to the top and it will be bent and kept. Then another type of rig that is available is a very small diameter rig, and is mainly used for continuous flight augers and used for screw piles. Screw pile means the diameter will be small and the amount of the reinforcement that is used may be 3 or 4 or the less one. The advantage of this type is it can be large number of piles can be done in a day. If you go for DMC piles, generally people do only 2, at the most 3. More than that is not possible, because soon after the boring you have to do concreting. That is essential. Otherwise caving may take place. Next day if you start coming and doing concreting, again you have to do reboring. That is required. Even the rotary boring also, the number of piles are restricted, or the number of piles that you can achieve is less, whereas in this small continuous flight auger you can do large number of piles in a particular day. Now this is mainly used for small loads, not for large loads. Especially this is used for, say, making ground improvement where the soil is very soft and soil is very, very soft and you want to make some yard where you want to store some material, something like a shipyard, etc. In such places one can go for this type of method, and it will cover large area in say a very small period. That is helical augers, screw type of, or screw or flight augers are used. Now This sketch I am just showing you what is meant by pile cap. Pile cap is a structural element which will be in between the superstructure. These are the columns, and below this you will have the piles. So this is a pile cap, a structural element. What it does is load from the, we are assuming that the load from the column will be well distributed in the pile cap, then it will be transferred to the pile. Now you can see in the pile cap, the reinforcements will be taken up to the top and bent properly and kept. You can see here the reinforcements of the piles. And the practice that we are following is the reinforcements will be kept at the top but below the top layer of the reinforcement. You can see the person sitting here also you can see the reinforcements are bent. You cannot cut the reinforcements and keep in the vertical in the pile cap. The contractor may have a tendency to cut vertical because the working will be easy. Otherwise he has to put the reinforcement. Putting the reinforcement will be slightly difficult. Then there are many methods of laying the reinforcement. It may be based on the theory also. If you go for the what is known as beam theory, we will put the reinforcement from pile to pile, and only skin reinforcements will be put as like this. If you are going for truss analogy, we come across bottom reinforcements, we come across top reinforcements, then we come across vertical reinforcements also if necessary. So depending upon the theory that you are going to follow, either the truss analogy or beam analogy, the arrangement of the reinforcement in pile cap will be slightly different. For example, if you go for 3 piles, you can put pile to pile main reinforcement. Sometime just to support the column, we will provide in that diagonally also. The amount of the reinforcement that is coming in the pile cap will be huge because we have bottom, we have top, we have vertical members, etc. Then I am just showing you another pile construction in the say Z. What is done is, in order to make the actual piling, people will be making temporary bunds and making some small piles. That is just to support this platform, and that will be continued from one end to another. Then once that is completed, this rig, in order to support this rig, these piles are used, and you can see this pile rig movement, and the end one will be a cantilever one, and the end of this cantilever rig, cantilever platform, you will be keeping the rig and inserting your boring system, and you will be making the actual pile here by making the bore hole and filling with the concrete, etc. You will be doing this. Once this is over, slowly this platform will be moved in the forward direction and go to the next point. So one can easily calculate what may be the maximum cantilever that you can do, what is the minimum number of the dummy piles that is required, etc. That can be pre-calculated, and accordingly people will be working. Now this sketch I am just showing you in order to show that after pile chipping what they will do. And another one, say people are using what is known as touch piles. These are known as touch piles. Instead of sheet piles, people are using touch piles. Touch piles are say inserted into the ground very close intervals. Sometimes 2 layer or 3 layer will be used, and after using this, touch piles will go below the proposed level by 1.5 times. That can be designed, and after doing the touch pile, people will be removing the soil and go to the required depth. Then the reinforcements will be taken here, and you can see here the pile is made slightly more than the existing ground level. On this only pile cap will be say prepared. So this sketch I just projected to show what is meant by this touch piles. And second one is, after pile chipping, you will be rebuilding and making slightly 5 centimeter or slightly more than that. On that only the pile cap casting will be started. And this few slides just showing you what is precast piles. You can see in the precast piles, the reinforcements in the tip will be very, very large. And some people are using shoe also here. so that it should not get broken while driving. And the mix used for concreting also will be more than the conventional type. So this is how the precast piles are made. Now the length of the pile depends upon the rig that is used for casting. Now you will make this type of pile and keep ready for driving. And this is just showing you how this precast pile will be lifted. This is a 2-point system that is used for lifting. We have different methods, 3-point, single point, etc. Then these precast piles can be driven even in the inclined direction. Then say you can see here the piles will be driven, and after driving, say we cannot, if the pile required is 40 meters, we cannot drive in one stretch. Different machineries are used, drop hammers are there, hydraulic systems are there, semi-hydraulic systems are there, and the efficiency with which the load carrying capacity can be calculated based on the weight of the hammer, the amount of penetration, etc. can be related, and we have different formulas for the calculation of the load carrying capacity. Then say the point I want to show is we cannot cast the pile in one stretch. So there will be joints in the precast piles. Theoretically, we prefer to have joints in the bottom. For example, we are casting at 12-meter length, and say the actual pile length required is 20 meters, then 12 plus 8 will come. And we prefer to have that joint at 8-meter, 12-meter below the ground level, so that sway or horizontal thrust will be taken care. Whereas from the practical point of view, generally the joints will come in the top, so that will be weakening your pile. Then you can see how the joints are made. You will have some threads which will be going inside the second one, and there will be proper locking also in between, so that they act as a single unit. Now this is precast say circular piles, and that also is used for different functions. This is kept as a batter piles. This part I am just keeping. Now I'll go to the another small one, that is pile testing. Now we have different types of testing systems as per the code. Conventional testing, that is known as gravity loading, can be done, and that reaction can be generated by keeping the loads on the platform, or by anchor beam or truss system can be used. And this is a time consuming process for the load test, but it is mandatory that you have to confirm what is obtained from the theory and what is casted. You have to confirm before going for the superstructure construction. So it's a time consuming one. So people are going for integrity testing as well as a dynamic pile test. Both are possible nowadays. I'll be showing this some sketches for this. And if the structure is very tall and you want to ensure that the settlements are within the limit, you can do some instrumented piling also during casting. Some of the piles you can do some instrumentation, and during construction of the superstructure you can take the readings and ensure that the settlements are within the limit. Now you can see here, this is a pile load test arrangement. Whatever my arrow moving is the pile, and on that you have kept hydraulic jack, and this is the inner ram, this is the outer ram. Then a string of steel rods will be kept, and the dial gauges are kept in the proper positions. Now as per the code, 3 dial gauges has to be used at 120 degree apart. Then we have the standard procedure given in the code that I am not explaining here. Now the reaction has to be generated, and if the pile, we are expecting that it will take 100 ton, at least 150 ton load has to be, pile has to be loaded up to 150, and reaction may be 180 or 200. Such loading we have to keep it in the top. This may be due to gravity, or like an anchoring system or some truss system. Anyone can be used. Here we are following the manual reading. We are going very close and take the reading. You can use some instruments also for taking the reading. That is also possible. That is also possible. This is now this is a time consuming type. because you have to cast the pile, level it by plastering, then you have to keep this and do the testing. All together it may take months. Now another method is known as integrity test. In that integrity test, we'll have a soft, say we will fix some small fitting that is available in the instrument. Then with a standard hammer, we'll give a kit. When you give the kit, the waves will be moving up to the bottom and come back, and you will have a transducer. It will be absorbing this mechanical energy, convert into electrical energy, and give you the graphs. Automatically standard softwares are built in. You will get velocity with the time graph. The violet color graph you will be getting. With the help of this reading, you can see here if the pile is having some projections like this, you will get a ridge in the graph. If you have projection outside, you will get a valley. So depending upon the shape of the graph, you will be able to judge whether the pile is uniform or not. That is one. By velocity time graph, we will be able to judge whether the pile is uniform. Then we will be able to calculate, or there is a knob with the help of which you will be able to calculate the load carrying capacity of the pile. That is also possible. The advantage of this is the test can be done in no time, and you will be able to test all the piles that is casted. That is another advantage. The disadvantage is this concrete will have aggregates, fine aggregate, and sometimes small holes may be there, and wherever you hit, the graph will be varying. If you hit on aggregate, you will get one graph. If you hit on fine aggregate, you will get another graph. So 100% reliability cannot be achieved, because the same pile I can get lot number of variations. So a good interpretation is required for the analysis. An interpreter is required for the analysis. Then only we'll be able to tell whether the pile is safe or not. That has to be taken care. Now this type of testing is can be done. Suppose some builder has made piling, then he is stopping the project, and if we want to sell, the next person, how to believe that take the load? One can do integrity tests on all the piles and do some statistical analysis and see that the results are satisfying. Like that one can use. Disadvantage is this is not 100% reliable, because I told you the concrete may not be uniform. Wherever you hit the same point, if you hit, you will get different values. That is one of the observations. A better one is dynamic testing, where you can keep the acceleration pickup and the strain gauge at some particular distance. I think it is around 1.5 meter below the top, and with a heavy hammer weight is generally taken as 10% of the pile, and you will be giving a hit, and with that some vibrations will be generated, and this is connected to a measuring device which will give you the load carrying capacity, homogeneity of the pile, etc. can be obtained. And compared to this dynamic testing, this is better than the integrity testing. And there are cases, some places people do some dynamic tests, some gravity testing, etc., etc. Now this I am just showing you. Just if you want to do exact analysis, we'll go for finite element. That is, each one will take as a say discrete element and try to apply the load, vertical load, horizontal load, and lateral load, and do the testing. That can be done. Now this type of reaction is also possible for small load tests. With the help of truss, you will be able to load it, and you can see these are the reaction points. This is the pile point. We will be able to do the test pile. Now here also people have modified by their own thinking. Many techniques are available. Some people are keeping some tanks on this, loading with the water or some material. You can do the testing. That is left to the concerned engineers. But the procedure for loading test is same. That is, you have to apply a seating load. This is the gravity loading. You have to apply a seating load, then remove the load, then the load at a particular interval, you have to apply the load, wait for some particular time. As per the new code, there are small variations are there. Then you have to go for the next incremental load. Like that, you will continue till you reach the settlements, or then you will unload. Like that, the procedure, there are some standard procedure. For example, in the earlier code, the rebound also will be considered. In the present code, rebound is not considered. Like that, small modifications have come in the code. This is arrangement of the loading in sandbags. This is the test file. This is the hydraulic jack. On that, string of rods will be kept. Then a single cantilever type ISMB will be kept on that small ISMBs. Then we'll keep the sandbags. That is how the testing has been done. Now this I'm just showing you a pier. I am not going in deep pier, and nowadays below this pile foundations are used. Then we are using deck. Then you can see here the resting will be one part will be fixed, other part will be free moving, and you will have a joint here that will be say closed in a proper way. Then this is the well foundation. You will make the edge, cutting edge. Then you will cast layer by layer, 1.5 to 2 meter layer by layer. Then start digging and see that the well will start going down. Sinking will start going down. The difficulties are when you come across some hard rock, etc. There is a possibility that it may get tilted. Such possibilities are there in the field. That has to be taken care. So you have to rectify. It takes a lot of time. And say in a hurry, if you make this well, 3 or 4 layers all together, because casting at 2 meter and casting at 4 meters, the labor involved is same. So if you make some 8 meter and start digging, if the tilting occurs, rectification will be a difficult thing. Now I'll go to the last one. This is regarding IS 2911 Part 3 1980, the design of underrim piles. Nowadays, underrim piles are not that much used other than for small structures because of these difficulties, and load carrying capacity will be lesser. But still, for small structures, people are going with these underrim piles. A board, this is a underrim pile means a board cast in situ board compaction concrete pile with enlarged bulb at the bottom either by cutting or by scooping out of the soil or by any other suitable process. In the bottom will provide a bulb. It may be enlarged base, inverted cone, or is formed in stable soil, allow very high load bearing capacities. Now this particular code is used for construction of the underrim pile. Now it may be board cast in situ pile or it may be board compaction concrete type. Even board pile means we will make the bore, fill it with put the reinforcement cage, then fill it with the concrete. Board compaction concrete pile means we will make the bore, then fill it with the concrete, then reinforcement cage will be pushed by some hammering or some technique, that is board compaction pile. Now in the case of board compaction pile, the load carrying capacity will be 40% more than board cast in situ pile. Now the piles may be made with one or more bulbs to resist uplift, and it can be used as anchors also. These are the two mainly advantages. Now this can be used for undesirable layers like expansive soil, black cotton soil, small filled up grounds, and laterite quarries where if come across and you want to make single story or 2-story, or small structures where cover level has to be controlled. All these places can be used. This is what is given in the books. I wrote loose to medium pervious sandy or silty strata, etc. This can be used. Now in the design we have a lot of parameters. One is pile diameter. What is the diameter that is to be selected? Second one is what is the spacing, what is the stem diameter and the bulb diameter ratios, etc. Some specifications are given in the code. For example, the diameter of the underrim bulbs may vary from 2 to 3 times stem diameter, Then piles up to 30 centimeter diameter. The spacing of bulbs should not exceed 1.5 times the diameter of the bulb. Then the piles diameter greater than 30 centimeter spacing can be reduced to 1.25 times. Like that, lot of specifications are given. Now, the bulb should be kept in such a way that they will not touch the bottom. That is for small diameter piles, that is the problem. That's why they are given a range. But generally people follow 2.5 times the diameter of the stem diameter. The bulb diameter is 2.5 times the stem diameter. The bulb can be kept at the bottom, but practically some people are keeping one at the bottom, one slightly above in a group. This is a typical sketch of a underream pile. You can see the bulb, and you can see minimum bucket length will be left out. Then the distance between the bulbs, etc., specified in the code. Strictly we are following this in the field. Now, load carrying mechanism. It can be designed as a structural member, as a column, or it can be considered soil strength and do the calculation, and whichever is weak, that will be considered. Now, reinforcement required is very, very less. 0.4% reinforcement is sufficient in the piles, whereas in the column we used to go with the 0.8%, and the number of bars also it is less. For example, we can go with the 4 number of bars, 12 mm bars, whereas in the column we have to provide 6 number of bars. That such variations are there. Now the code has given some formula for the load carrying capacity, that is APE. Some formulas are given. Basically it covers two components as end bearing, two components as frictional. Here the frictional component is given in for the sandy soil. The frictional component is given in the summation form. Now 2 parts are end bearing, 2 parts are frictional. Now I'll just show here at the tip we'll have end bearing. Then here inclined portion, if you project, there will be some end bearing we can get all round. Then the frictional component along the stem from bottom up to this, then from here up to the top we will get the frictional resistance. Then we will have the frictional resistance from this inclined bulb portion. If you take vertical component, we'll get some frictional component from this. So 2 frictional component, one is from the bulb, one is from the stem. 2 end bearing resistance, one is from the bottom, one is from this projected one. That are the one which is used in this formula. In the case of clay soil, we will use cohesion. In the case of sandy soil, we will use angle of internal friction and modify the formula. This part I am not going in detail. And if n values are available, we can convert into 5 value and go for the frictional components. Now, spacing of the piles depending upon the space available, collar load, etc., we have to consider. And lesser the spacing, load carrying capacity will be reduced. Larger the spacing, load carrying capacity will be more. And larger the spacing, pile cap will be more. Like that, we have to consider all the factors and come to the pile spacing and ensure that the bulbs will not touch each other. And say this already given, showed you this table for the load carrying capacity that is available. Either we'll go with this or we'll go with the formula. And after getting this value, we'll be modifying this based on the n value. For example, n values are very, very low. Then we have to reduce by some 25%. If the n values are high, we can increase by 25%. The water table is high, we can reduce by 25%. Like that, some clauses are given in the code that can be used, and finally we will arrive at the load carrying capacity. Then regarding the pile cap, the pile cap is the structural element that is be acting in between the pile and the superstructure to transmit the load. Then plinth beams. Plinth beams, as per this code, we can go even WL/20 to WL/30. For example, if the plinth beams are resting on the ground, natural ground, we can go WL/30. If it is not resting on the ground, we can go with the WL/20. So these are the things I would like to cover today. I'll be stopping my sharing. And I would like to spend some 10 minutes for any clarifications. And before that, I would like to thank all of you for hearing me 1.5 hours, a long session. And I covered a lot of PPTs. I don't know how fast I have gone. One of the point I would like to stress is the calculations that we are getting. Calculations that we are getting may not be working in the field. That is one of the observations that is seen at, and based on the field conditions, slightly we have to modify. Now I will leave to Dr. Hari, and you can carry on the session. For any questions, I am ready.
Thank you, sir. Thank you, sir. For very elaborate lecture, and I would like to have questions from the candidates. If you have any doubts, you can ask, sir.
If any questions are there, we will do in the discussion mode so that others can also participate.
Participants may interact now. You can unmute your mic and can ask questions related to the topic to Chandrakaran sir.
Okay, if there are not much questions are coming, so I would like to inform you that one of the problem that I faced in a Mangalore refinery, N values are 0, and the piling was very difficult. So finally, the design has modified with the liners. Small liner has been introduced. Similarly, in Trivandrum, in one of the building, sandy soil was there, and the people were reporting that whatever pre-calculated concrete was not going. So with a very great difficulty, by controlling the bentonite and the method of concreting, we were able to do to some extent. That is satisfied. Around 80% of the concrete has gone in. Like that, from it is not say a unique solution, something like M20 concrete we will get. Pile means each project, our experience is different, and accordingly we will modify slightly. We will go away from the code and slightly modify. That is the real practice that is happening. I hope others also, those who are practicing, they will also agree with me. If no questions means we'll stop. And if you have any clarification, you can send mail also. I'll try to answer.
Thank you, sir. If participants are having any questions, they can unmute their mic and ask questions to Chandrakaran sir. Okay, we are not having any questions. So thank you, dear Chandrakaran sir. It was an honor to have you as a chief guest. I sincerely hope that all the concepts shared by you will benefit our participants. Thank you for sparing your valuable time for us. Thank you, sir. Thank you. Thanks a lot.
Thank you for the coordinators and the participants for hearing me 1.5 hours. Thank you. Thank you very much. I'll leave.
Thank you, sir.
Okay.
Dear participants, with that, we wind up our first session. Our second session will start at 12 p.m. and that session will be taken by Dr. N. Durga Kumar, Professor, Jawaharlal Nehru Technical University, Hyderabad, and the session will be on in situ characterization of soil and its behavior under dynamic loads. So we shall stop now, and I wish and I thank everyone for being here. We shall meet at 12 p.m. Thank you.